Good evening. I welcome you for the week 4 session on subsurface exploration, importance, and techniques involved. So, in this session, we'll see about geophysical methods, which is a non destructive testing method for the exploration of soil and site condition. So, in this class, we'll see about how to solve the related problems also. So geophysical test, as I said, they are the indirect test which is conducted at the sites when we cannot when we have a very large area, and also we it's not possible to do borehole for the entire site. And also in our borehole results, if we have lot of uncertainties, or there is a continuous change in the strata, all those if it is present, in order to have a supportive data, we can do geophysical test. They can give you quick results instead of instead of doing drilling borehole and inserting the sampler and avoiding such things. It is a very simple and easy to perform the test, but the only issue is it's quite costly when compared to the our conventional boring methods. So they are the non-destructive test, and also there are some issues like when we are going to have surrounding disturbances like vibrations, such things around like traffics, all those can affect the result. So we have to be very careful when we are performing the test to avoid any vibrations coming from the external environment. And it also can be done for a larger depth. Okay, so if you are not able to progress our borehole for from the, excuse me. So when we are not able to progress the borehole after certain depth because of the hard stratum or a rocky stratum. Okay, so instead we can perform a geophysical test in order to analyze or in order to confirm that stratum. Okay, sometimes a boulder also maybe got struck at the bottom. We may think it is a hard stratum, we have it the hard stratum, but once we do a geophysical test, then we will be confirming, okay, that is could that could not be a hard stratum really. Okay, so this is like supportive test which is done for the test results that we obtain by boring, or it can also be done before starting any boring or test pits. Okay, because it's, in order to have an idea about the strata, what type of rock or what type of drilling it may require, what type of strata it is present, depending on that only we'll be choosing what type of drilling method we need. Okay, so we can do a geophysical test, and we can see whether to a larger depth a soft strata is present or a hard strata is present. Such things we can determine. So we can measure the physical properties of the subsurface characterization and identification. So in uh, geophysical methods, we have lot of different types of testing methods. One is going to be seismic resistivity method. So in seismic resistivity method, we will be having four types of waves actually. Four types of waves like primary waves, secondary wave, low wave, and Rayleigh wave. So this primary wave, they cause a compression motion to the system whichever they pass through, and this shear wave, that is your S wave, they cause a shear motion to the system. Because of this S wave only, we are getting lot of damages during earthquake, especially during earthquake. S wave is a predominant wave being generated, and which can cause a destruction to the system. Whereas P wave, it just causes some compression and tension, just some pulling and pushing kind of forces will be applied. Okay, so it doesn't cause much disturbance to the system. And we have other waves that travels on the surface, that is going to be surface waves, that is love waves and Rayleigh waves. So love waves, they will be in they cause elliptical motion, and whereas your Rayleigh waves, they cause a translation motion to the strata. So there are two types of tests. One is seismic refraction method and seismic reflection method. So in seismic reflection method, we the geophones or detectors will receive only the reflected waves. Okay, whereas in seismic refraction method we get three types of waves, that is direct waves and refracted waves and reflected waves. So geofence can capture three types of waves here. And the next type, other than your seismic resistivity, one another type of test is going to be electrical resistivity method. So in electrical resistivity method, what we do is we send current we to the stratum, and we measure what is the resistance offered by the stratum through the potential drop measured. So we have a current electrode and you have a potential electrode, two types of electrode. So this electrode will be applying the current source. So this will be applying the current source, and this will be measuring what is the voltage drop. Okay, so we'll be having two types of flow lines we can call, like, or current lines and and your potential equipotential lines. So this current lines, as you can see, they are of confocal ellipse shape, whereas this equipotential lines, they are of confocal hyperbola shape. Okay, and they intersect exactly at 90 degree. So we measure what is the resistance offered by the layer. If it is going to be a hard strata, the resistance will be more, whereas if it is going to be a soft strata, the resistance to the current will be very less. Okay, so depending on the uh, value we get, we can guess. Actually it is kind of a, rough estimate of the stratum. Okay, it is not much sure, but we can get some rough idea about the stratum. In a electrical resistivity testing, this is a typical graph which we obtain. This important to understand. See, when we have a homogeneous stratum, that is the layer is of same type to a larger depth. Okay, so when you're going to having a homogeneous stratum, with the when we increase the spacing between the electrodes, okay, so the resistivity is not going to change. So this is how a horizontal line we get in a for a homogeneous stratum. If the stratum is going to be, if your site is going to have a low resistivity layer first, and below we have a higher resistivity layer. So once the current passes through a low resistivity layer, it will be having a low resistance, but once it goes to the higher resistivity layer, you can see that the resistance increases. Okay, so this is how the curve B is obtained when you have a low resistance above layer above, and below you have a high resistance layer. Whereas C, which is going to be the mirror image of B, if we have a very high resistance layer, very thick rock kind of layer in a shallow depth, and below that rock you have a soft clay. Okay, so such kind of stratum will have a graph like this. And D, when you have high resistivity layer between two low resistivity layer, that is sandwiched between. Okay, so imagine you are like a bread sandwich kind of. So in between you have a hard layer. Okay, and top and bottom will have the soft layer. Okay, so a high resistivity layer will be sandwiched between the low resistivity layer. And E is going to be presence of vertical discontinuity in between the high resistance layer. So when you have a vertical discontinuity, it means kind of fissures or gaps kind of things in a in between the high resistivity layer. So this is a typical graph that we get in a electrical resistivity testing. So we usually increase the electrode spacing and we measure what is the resistance. Okay, so there are different types of arrangements, like Venner and Stumberger arrangement. It depends on what type of project. See, for example, if you have a highway project, we are much interested in a laterally how the stratum is spreading, rather than with the depth, because in a highway, the stress is not going to travel to much deeper depth. Okay, so what we are much worried is along the distance of the highway, how the layer is going to vary, or how the stratum is going to vary. So such type of project, we use a different array. And when we are worried about for larger depth, I need to find what is the stratum spreading. Okay, or what type of stratum is present in such kind of project, we'll be using another different type of array. So in seismic survey, beyond critical distance, dash type of waves will be for reaching first at the geophone. So critical distance means where you are beyond that critical distance, you are I can show you a picture. Yes. So when you plot a time versus distance, so critical distance is that where your direct surface wave as well as your refracted wave will reach the receiver simultaneously. So this is your critical distance. So beyond that critical distance, we will have only refracted waves reaching the receiver. So the answer is going to be refracted waves. But at critical distance, at that point, exactly at critical distance means you'll have both direct wave and refracted wave reaching the geophone simultaneously. Okay, so beyond it, beyond the critical distance, we will have only refracted wave. Okay, in a seismic refraction test, the following data were recorded. The soil profile at the site is considered to be horizontal. So we are conducting a seismic refraction test. Okay, and the distance between the geophones are given. The distance is given, and the time of record of waves are given here in millisecond. Find out the distance from the source where the direct wave and refracted wave will reach simultaneously. So they are asking the critical distance when when the direct, it is the distance at which your direct wave and refracted wave will reach simultaneously. So this DC is what they are asking. Okay, so I have plot, initially we have to plot a graph. So what do we do is, are you able to see this graph? Hello, are you able to see this graph? Ah, yeah, okay. If you have any doubt, you can ask. So the given data is distance between time, distance and time. So what we have to do is we need to find the critical distance. Okay, so the formula for critical distance is going to be for find the thickness. From that we are going to find out DC. So if you need to find the thickness of the strata, the formula is H equal to DC by 2 square root of V2 minus V1 by V2 plus V1. Okay, so we need to find what is DC here. So first what we will do is we will find what is the, how to, yeah, I'll explain 1 second. V1 V2 are the slopes. Okay, so find out the distance from the source where the direct wave and the refracted wave will reach simultaneously. So I have plotted the graph 1 second. Yeah, so this graph, in this graph what we have to do is uh, we have to straighten this portion, kind of a tangent. Okay, so straighten this line and straighten this line and meet, see where it coincides. Okay, so this distance is DC. They have not given H value, the thickness of the stratum is not given, but from the option we have four options, right? From the option you can see that the value C, that is 22.75, we need the value between 20 to 40 meters. Just we have to plot the graph. Okay, just plot the graph, extend this portion, extend these two lines, so see where they are intersecting. So the answer is between 20 to 40. Okay, so if they have not given the option, we can directly take any approximate value. So the answer is going to be between 20 to 40. So the option between 20 to 40 is going to be C value, 22.75. So that is our distance from the source. Understood? Hello, is this clear? We have to plot a graph. Yeah, this is the graph. Actually I have extended the line. This is how you will get the graph. Okay, so once you get the graph, you have to draw this tangent lines, kind of. Whatever you plot, your value is going to be between 20 to the 40. Okay, so The answer is going to be between 20 to 40. From the option, the only value between 20 to 40 is going to be, no, no, I'm distance. This is distance. Okay. This is critical. This x value. This value is going to be your DC. You have to get the, this is your DC value. Okay. Your x axis value. That is the distance. Distance versus time we are plotting. They are asking what is the distance at which they are going to reach simultaneously. So obviously you have to take the x value. Okay, at this distance of 22 meters, the both the waves are reaching simultaneously. You cannot take time. This is time scale. Clear? Okay. So the next question is, so we have got the DC value as 22.75. Just plot the graph and extend the lines and see which value suits your option. Okay. The next is referring to the question 2, what would be the thickness of the superficial layer? So they are asking what is the thickness of the layer. So H is the thickness. Okay, so H equal to DC by 2 square root of V2 minus V1 by V2 plus V1. So how to get this? In this we have DC value. How to get V2 V1? V2 is nothing but the slope of this first line. That is going to be your inverse. Okay, so 1 by v1 I have put in the excel. See here, what I have done is, one I have measured what is the slope. 1 by v1, 1 by v1 equal to, yeah, that's what I'll tell you. Wait, you can see here I have chosen 2 points, that is 1023, and this point is going to be 2049. This is 1023 point, and this point is going to be, I'll just move this line away. Ah, see, 2049. So I need the slope of this line. Slope of the line is nothing but dy by dx. Slope is dy divided by dx. Dy means difference in this vertical portion, and dx means difference in the horizontal portion. So this slope value you need, which is going to be dy by dx. Dy means, as I said, difference in the y-axis value, and dx is difference in the x-axis value. That is your slope of a line. Okay. So what I have done is dy 49 minus 23. Dy is nothing but 49 minus 23, and dx is nothing but 20 minus 10. Now you have to divide both values, dy divided by dx. So you get 2.6. This is nothing but 1 by v1. 1 by v1 is the velocity of your this one direct wave. Okay, so 1 by v1 is 2.6. So v1 is inverse of this value. So 1 divided by 2.6. 1 divided by this value, that is going to be your v1 into 1000 we have to do, because it is in millisecond. Okay, so this time is in millisecond. That is 10 divided by 1000, or else I can put here. We need the value in the meter second, divided by 1000. Yeah. So we have to multiply this with 1000. Then the value will be coming in meter per second. When we do this dy by dx is in, you will have 1000 here into 10 power minus 3. So it comes to the numerator means you will be having, I don't want to do it again and again. So into 1000 I have multiplied to convert that into meter per second. Dy is the y value difference and dx is the x value difference. Okay, dy by dx, this dx is in millisecond. So in order to convert that into meter second, see this is in denominator means it is in 10 power minus 3 in in the denominator. So when it comes to numerator it becomes 10 power 3. That is why here it is getting multiplied. Don't think like why millisecond to meter second is multiplied by 1000. This is dy by dx, this is in denominator, so your 10 power minus 3 is here in the denominator. So when it comes to the numerator it becomes 1000. Understood? Hello? Did anyone not able to is not able to understand this? You can tell freely. Is anyone not able to understand? And up to which point you are clear? You are clear with this plotting the graph, right? The graph is clear. How to get the dc value, that is your critical distance, is clear. So we have got the critical distance. Now we have to find out the v1 v2 value. Okay, v1 v2 value is given by the slope. First we have to find the slope. Okay, so here the slope of this line we need, which is nothing but dy by dx. We measured slope tan theta equal to dy by dx, we tell now, that is you are opposite by adjacent. So this is tan theta, this is a angle. Okay, we no need to find theta here, but opposite by adjacent, tan theta, that is a concept. So this inclination, if you need the theta value means we will be putting tan inverse of this value. So the slope is nothing but dy by dx, it is general common. So dy 49 minus 23. From here you have to minus, so this length you need. Okay, actually you need this length. So how will you get this length? So from 0 to 49 minus 0 to 23, so that's how you get this length. Correct? Imagine it, if it is, this is, imagine if it's a 50 point 50. Okay, I need this length. So 0 to 50 minus 0 to 20. If I do, I'll be able to get the length of this line. That is what I am finding. So here up to this point it is going to be 49, length 49. Imagine. Okay, not okay. So 49 minus 23. So I'll be finding what is this vertical value. Next, I need this small horizontal value. So that is going to be 0 to 20 minus 0 to 10. So this smaller length I will be able to find out. Okay, so 0 to 20 minus 0 to 10, this value. Okay, so you'll be finding what is the dx value. So dy by dx is going to be your slope. Okay, so we have got dy by dx. Now this dx which is in denominator, it is in millisecond. So millisecond, I am converting this millisecond into meter. Tell me how much 1 meter, how much milli it is. 1 meter how much millimeter you tell. Milli is the giga, tera, peta is just a value. Mega means 10 power minus 6, giga means 10 power minus 9. Mega means, see, 10 power minus 6. Similarly, milli means, the term milli means 10 power minus 3. Okay, that's why we call that as a millimeter. So milli means 10 power minus 3. So you have a 10 power minus 3 value here. That is your denominator. Okay, so I am putting 10 power minus 3. When it comes to the numerator, it becomes 10 power 3. Hence I am multiplying 1,000 here in order to convert that into a meter per second. 1 meter is going to be 1,000 milli. Okay, so 1 milli is going to be 10 power minus 3. When this 10 power minus 3, which is in numerator, comes to the denominator, when it comes above, yeah, 2.6 into 10 power 3. Yeah, I can put here. Okay, I'll put here, no issues. Into 1,000 I'll put. Okay, so now whatever the answer you get is in, actually this 1,000 will be in denominator. It comes in the denominator. This is in millisecond. Okay, fine. Now this is in millisecond, right? This is how you get, you forget about this conversion now. So 26 10, when we get it, this is in 2.6, which is going to be in and time is in millisecond, and this is in meters. Okay, so in order to make it uniform, we'll divide this by, we'll put this into 10 power minus 3. So this you will be having 10 power minus 3 here. So you'll have a 10 power minus 3 here. I don't know how to put it in, then it comes meter second. Okay, so 26 meters divided by 10 into 10 power minus 3 meter second. Okay, so now we'll have this divided by this. So this 10 power minus 3, when it comes to numerator, it becomes 2,600. So V1 is going to be 1 divided by this value. No, no, 1 by V1 is 2,600. 1 by V1. 1 by V1 is this value. Yeah, 1 by V1. The slope of the, you can see here, this slope will give you 1 by V1 value only. It will not give you directly V1. When you are measuring the slope of this line, see, velocity is velocity is distance by time. When you are measuring this, what we do is we are finding time by distance when we are measuring the slope. Am I right? Velocity is distance divided by time. So what we are doing here, we are measuring time divided by distance. So you have to find the inverse value. So when we do 1 by V1 only, we will be finding what is the V1 value, because this is dy by dx is, you, if you need the slope, when you're finding the slope, it is time by distance is what you get. The value we get here is, hence we are doing 1 by V1. Yes, 1 second, yeah. I'll just clear this once again about yeah. We have to multiply this value with 1000. That's how we get. And I'll clear this now. Okay, for time being, just we'll keep this aside. So we get, this is clear, right? We find the slope dy by dx. Whatever the slope you are finding is 1 by v1. We have to find what is v1, just nothing but 1 divided by this value into 1000. Okay, this is a little confused between the units. It's nothing but the conversion between the milli and the meters only. But from meters, when we are converting, we have to multiply this with 1000. So this is meter per second. We will get this value. I'll come back to that later. So we'll get v1 here. Similarly, v2 we have to get. So this is the slope of this. Yeah. Mm, yeah. 1 divided by 2600. Hey, I'm not getting that value. I'm getting some 0.004. Wait, I'll just. Okay. 1 divided by 2600, you are getting. I'm getting 0.0004 only. Yeah. See, that 384 is what the correct answer. No, 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 wait. So this is in meters, right? So you'll get, then this is in milliseconds. Milliseconds. Now to convert this into seconds, okay, what we have to do is we have to divide this value by 1000. This value has to be divided by 1000. So then we will get as a meter second. So it is 0.01 meter second. Okay, so some calculation error is there. I don't. I'll come back this. I'll come back this for just give me some 5 minutes. Okay, I'll come back to this. But we'll find the slope as we'll find what is a v1 velocity, and we'll find what is the slope here. Similarly, I have taken 2 points. Okay, these 2 points I have taken. So 75 minus 68 divided by 80 minus 60. Once if I do it in my pen means I will be able to do much clear. Then once we find the slope, we divide it with 1 divided by the value into 1000. Okay, so that we do. So we get the v1 and v2 velocities. So once we get v1 v2 velocity, time being you understand that you have to find the slope dy by dx. Okay, if it the unit is in millisecond means for the final v1 you have to multiply with 1000. So once you multiply with 1000, you'll be able to get in meter per second. So this v2 minus v1, find what is v2 minus v1 and v2 plus v1. So directly we have to substitute this in the formula. So our dc by 2 square root of v2 minus v1 by v2 plus v1. So we will be getting 9.93 meters. I'll come back to that conversion shortly. Okay, after the finishing all the question, we'll come back again. So the answer is going to be 9.87 meters. So we are getting approximately same answer. That is the thickness of the layer. So for the same question, if the obtained values, that is your V1 and V2 are interchanged, what would be the thickness of the superficial layer? So this is if we are interchanging our V2, V1 values. What happens if the V2, V1 values are interchanged? When we do V2 minus V1, we get the answer in negative. Okay. So it is not possible when we cannot find the square root of that negative value. So when the v2 and v1 values are interchanged, the thickness is not applicable. We cannot use that value for the finding the thickness. So that is the answer. Someone's mic is on. Okay. So these things are clear now. I will come back to that in 2000 point later. Okay. But instead of other than that, whatever calculation we are doing here, that is finding the slope and dividing that slope 1 by the value will give you the v1 value. Okay. So the next question is from seismic reflection survey. A loose deposit of sand is underlined by bedrock. During a seismic reflection survey, the receiver marks the arrival time of directed and reflected wave. So we get this is your directed wave time 50 millisecond, and this is the reflected wave time, that is 300 millisecond, as a result of impact loading at 45 meter from the receiver. The p wave velocity of the sand layer is. So they are asking what is the p wave velocity. So we need to find what is L, TD, and TR. That is a formula. So your p wave velocity is the length of the source divided by the time of arrival of your direct waves. Okay, so Vp is equal to L by TD. So in this question, L is going to be this one. L value is 45 meter, and the time of arrival of your direct wave is going to be 50 millisecond, and your time of arrival of reflected wave is going to be 300 millisecond. So directly velocity equal to distance by time. So your distance is going to be 45 into 1000 divided by time. Okay. So we'll be getting 900 meter per second. So that 45 is a 45 is a distance from the source. Mm. This 50 is in millisecond. This 50 is in millisecond. This 50 into 10 power minus 3, it will come to the numerator. So it becomes 1000. 50 into 10 power minus 3. TD is in millisecond, and your L is in meter. So we need the value in the meter second. So I have brought the milli to the numerator. So when it comes to the numerator, it becomes here. In this concept only, the previous question also solved, but there is some mistake in where we are putting that 10 power minus 3. That will come back once the when after our class is over. Okay, so 45 into 1000 by 50. Your TD is in millisecond. Okay, I have not given the values here in order you to find it. So this is 45 meter, and your TD is going to be 50 millisecond, and your TR is going to be 300 millisecond. Okay, so we have found what is the primary p wave velocity. So the answer is going to be A. Next question is we have to find out what is the thickness of the sand layer. So the thickness of the sand layer, you can see they're asking you what is the H value. Okay, the formula for finding the TR, from the formula for finding the TR, that is your reflected wave time square root of L square plus 4h square by VP. Okay. So from in this they are asking what is the H value. Your TR is given. This is 300. Your L is 45. VP is 900 from your previous question. So we need to find what is the H value. So similarly here, so this is 900 and TR is going to be zero point 0.3. So first what I have done is, so TR is square root of 4h square plus L square by VP. I have taken this VP this side. So TR, this is your time of arrival of your reflected wave into VP equal to square root of 4h square by L square. So TR into VP. So zero point 0.3 is a time of arrival of the reflected wave, that is in milliseconds. So zero point 0.3. Zero point 0.3 meter per second into 900. TR into VP. Then, so we have found out TR into VP. Then what we have to do is we have to do squaring on both sides. Okay, so we have to do squaring on both sides to in order to remove the square root. So I have squared this value, squaring on both sides. After squaring on both sides, we have to minus the L square value with this value. Okay, so minus L square, that is 45 into 45. I will tell you once again. Okay, then after minusing, we have 4h square here. 4h square equal to this value divided by 4, divided by 4. Then finally we have to take the square root of the above value, which will give you the thickness. From that equation we have to derive. See, we need this H value. So TR into VP. TR, we have to take this VP this side. Then TR into VP, we have to do squaring. Squaring on both sides in order to remove that 4h square plus L square. Then we have to divide minus the L square value. So with this we have to minus the L square value. Then we have to divide this with 4. And finally we have to find the square root of this term. Okay, so that's how we get the H value. So that's what I have done this Excel. So first we know what is VP from the previous question. So find what is TR into VP, time of arrival of the reflected wave into VP, and your square root of square this value both are 2 times. Okay, then squaring these values, then minusing the L square value divided with 4 and finally find the square root of the above value. From that equation, if you get, you can get that H value. So the value is 133.11 meters. So your answer is here 133.1 meter. You have any doubt in this? I am getting this H value from this equation, and then we have to find what is the H value. We know what is VP here. TR, everything is given. So we can find H is estimated from this equation. That is a thickness. This one, question unit. This one. They have only three data. One is TD, TR, and your distance. Clear? Where, in which question you're saying? Okay, come again. Ah, okay, 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 okay. So lower layer is underlying higher resistivity. So you have below low layer, above higher layer. Okay. Ah, that means higher layer. See, instead of high low, we keep that as a rock soil. Soil is a low resistivity, and rock as a high resistivity. So in your first option, rock is lying below soil, and then the second option, soil is lying below rock. It has difference. Yeah, than rock when compared to the rock. In soil itself, sand has different resistivity than clay. Okay, so just to have a idea, we know that rock is if you low resistivity layer is underlying, they have given same thing for the two, same meaning for the two options you are saying. Okay, you first give any one answer, and you can mail the professor and ask this doubt. Okay, he may consider. You give what is the correct answer. Correct answer in the sense, two answers can be correct, or there could be wait, I'll open the question number. Can you tell? So resistivity is observed to increase. Okay, so resistivity observed to increase means, without seeing the option, can you tell what is the answer? Resistivity is about to increase. So in this, which is the curve? Hello, can tell me which curve? Resistivity is increasing. Huh? Here the resistivity increases with electrode spacing. They are saying now. The option could be either B or C. Here also the resistivity is increasing. Here also it is increasing. But you can see it actually decreases and then increases. Where here it is increasing continuously. So it could be low resistivity layer underlying higher resistivity layer underlying low. You are saying that option A and C are the same, right? That is right. Okay. The answer is actually B value. Hence, actually, these two are same meaning. Whereas, without even seeing the option, you can tell that once a resistivity is increasing, it means that it is the current is passing from a low denser area to a higher denser area. So the option could be, a higher layer is underlying a lower layer. Okay, pardon. You have to see the graph and tell. Okay, I cannot tell all the assignment answer. The answer is there in the graph here. Yeah. Okay, and you have a what is that, limestone? They have a values for yeah, resistivity values for the different materials in the video. So you can see that the question is between limestone sandwich between two layers means you approximately find what is the resistivity value and see whether they are between low resistivity layers or high resistivity layers. Okay, you can use this table and this graph. This graph will tell you the give you an idea here. Okay, so we're telling about this answer. Okay, so we have found out the thickness of the layer from the equation. The next question is for the same question. If we have a Poisson's ratio of zero point 0.3, what could be the S wave velocity? So to find out the S wave velocity, this is the formula. Your Vp by Vs, Vp by Vs equal to 2 times of 1 minus mu by 1 minus 2 mu the whole square root. Okay, so they are asking what is the value of Vs, the shear wave velocity. In this, we know all the parameters. Your mu value and the Vp value we know. So to find shear wave velocity, where your Poisson's ratio is zero point 0.3, so Vp by Vs equal to square root of 2 times of 1 minus zero point 0.3. Okay, so 2 into 1 minus zero point 0.3 divided by 1 minus 2 mu, that is zero point 0.6. Directly just a substitution only. Okay, so when we substitute Vp by Vs 1.878 we get. So from this Vs equal to Vp, that is 900 divided by 1.878, so we get 481 meter per second. Direct substitution in the formula. 2 into 1 minus zero point 0.3 divided by 1 minus 2 into zero point 0.3, the whole square root. Vp is 900, so 900 divided by this answer. So the answer is 481.28. Okay. Current lines and equipotential lines. So in a electrical resistivity test, the current lines and equipotential lines they intersect at 90 degree. For better result, the spacing of current electrodes and the spacing between the potential electrodes in a Schlumberger array. The spacing between the electrodes is very much important. It is like if you want to explore 3 meter depth, the spacing between the electrode should be 3 meter. Current electrode should be 3 meter. Okay, so and again it depends on the type of array, as I said. So if in order to have a better result, if the spacing between the current electrode, if it is twice the current electrode spacing should be greater than 5 times the potential electrode spacing. So your current electrode spacing multiplied into 2 should be greater than the 5 times the potential electrode spacing. The spacing, when it comes to electrical resistivity test, spacing plays a very important role. In a Schlumberger array, the spacing between the current electrodes is A and the spacing between the potential electrodes is B. The voltage difference is V. Current flowing is going to be I. So the apparent resistivity is a direct formula 2 pi A, pi A square V by 4 Bi. The direct formula. Okay. We'll go to that question. We'll change the units and we'll try to solve that. So till this, is everyone clear regarding seismic reflection test and seismic refraction test? Is this clear? This problem till that problem we are clear. Okay, that Excel, that one question by V1, that alone I will solve now. So what I have done is I have converted this into meter second. So this is in millisecond. I have divided it 1000. All the values I have divided 1000. So for 0.049 divided by 0.023. So this is our dy and this is our dx value. So dy by dx. We'll find what is dy by dx. dy by dx. Okay, so this is a dy by dx value, and v1 we need. So this answer divided 1 divided by this answer. See, we got now. We have to little bit have to come from the basics. Then only if I'm interpreting in the middle means no. So simple. I have divided all. This is in millisecond. I have divided everything into seconds. Seconds means I have just divided by 1000. Okay, so this is in milliseconds. So I divided all the values into 1000 so that they get converted into seconds. You can keep like meter second. Oh, okay. This I'm converting this into meter second. Okay. So distance by time. Meter. Sorry. I'm uh I'm just removing that milli value. That's what I want to tell. Okay. So it is in 10 power minus 3. Milli is 10 power minus 3. Why we have to divide it, multiply into the 1000? Am I right? Milli is 10 power minus 3. Milli is 10 power minus 3. So this is nothing but 11 into 10 power 11 into 10 power minus 3. This is what the value is. Yeah. Okay. Milli means 10 power minus 3. Ah, yeah, that's how I have divided. This is 10. When we bring this 1000 to the numerator, we put this as 10 power minus 3, right? The same value. I'm removing that milli. That is what I want to tell. Okay, this is nothing but 11 into 10 power minus 3. I have given here that. So now you will be getting correct answer. So dy is 0.049 minus 0.023 and your x value is 20 minus 10. Dy by dx 1 divided by dx. Now you will be getting exact value. Clear? Okay. Okay, thank